8.1, dilations. Starting out, a dilation is a transformation that either enlarges or reduces an object. And remember, a transformation means typically in the past we've moved objects. We've moved them left, right, up, down. We've reflected them. This time a dilation is going to take that object and make it either larger or smaller. The center of dilation is the fixed point about which a dilation takes place. And most commonly, this center of dilation is represented by C. So if you see a C, that's usually that fixed point. And if you actually look down here at this image, you have a small triangle, which has been dilated to make a larger triangle. And that fixed point about which that dilation takes place is C, which is the center of dilation. Then we have the scale factor, which is the ratio of side lengths from the image to the pre-image. Okay, which is telling you either how much larger or how much smaller the object became. Now, in this picture down here, P would be the pre-image, meaning the image before anything happened, and then P prime would be the image or what happened to it after the dilation. And then if you want to find the scale factor, you take P prime over P. That's the ratio you're going to use, and then typically your scale factor is represented by K. So if you see a lowercase k, we're talking about the scale factor. And enlargement is when the object gets larger. And then this is when k is greater than 1. So if you have a scale factor of 2, 3, 4, 5, etc., the object is going to get larger. And then a reduction is when the object gets smaller. And then this is when your scale factor is between 0 and 1. So if you've got a half or a third or 0.5 or 0.3 or something like that, your object is going to get smaller. Then we have our coordinate rule for dilations, and this means you can do a dilation in a coordinate plane. So if P, which is represented by x, y, is the pre-image of a point, then its image after a dilation centered at the origin 0, 0 with scale factor k is the new point P prime, which can be represented by k times x and k times y. Now, all this really means is that you're going to multiply coordinates by the scale factor, which will make way more sense when we get to example 4. Example 1. Find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So number 1, what we're looking at here is we have the center of dilation, and out to P, which is our original paperclip, it's going to take us 8 units. Then we're going to dilate our paperclip, and it looks to me like we're going to make it larger. Okay, so this is in fact an enlargement to P prime, and in order to get from the center out to P prime, we have 12. So if we want the scale factor k, you're going to take P prime over P, which P prime is the 12, over p is the 8, and then we're going to simplify that by 4, which is going to give us 3 halves. So your scale factor is that you multiply by 3 halves to make this object the new object. 3 halves is actually 1.5, which is larger than 1. So this is, in fact, an enlargement. Example 2, same idea. So this time we have P, which is the large paperclip, and then P prime, which is actually the smaller paperclip. So for finding our scale factor, we'll do P prime over P, which this time P prime is only the 18, over P, which is the 30. If we simplify that, we're going to get 3/5, and 3/5 is smaller than 1, which tells us this is a reduction. The paperclip got smaller. Example 3. In a dilation, CP prime equals 3 and CP equals 12. Find the scale factor, then tell whether the dilation is a reduction or an enlargement. So same idea, except this time we don't have a picture. So we are going to take our P prime over our P. Our P prime, if we're looking carefully, is right here, and that's 3. Our P is 12. And if we simplify that, we're going to get 1/4. So that tells me my scale factor is 1/4. So I'm cutting this thing down to 1/4 the size that it originally was. So that is a reduction.